Okay, welcome to the Errors and Uncertainties MCQ. We'll try to do this quickly. A student wishes to determine the density of lead. Density is mass divided by volume, but volume is mass divided by 4 over 3 pi r cubed. Now notice that the length measurement is cubed and the mass measurement appears on its own. So the percentage error in the density will be the percentage error of the mass plus 3 times the percentage error of whatever length is used, okay, to find out the volume. So the percentage error of the mass is 0.005 over 0.506. And then the percentage error of the diameter will be 3 times of 0.02 over 2.20. This converts to 0.037 or 3.7%. So the value is D. Next, a micrometer screw gauge is used to measure the diameter of a small sphere. The micrometer reading is okay. So once again, the volume will be kind of like 4 over 3 pi r cubed. So the percentage uncertainty in the volume will be 3 times the percentage uncertainty of whatever length measurement is used to determine the volume of the cube. So that or the sphere. So that will be 0.01 over 5.00 times 3. And the answer will be 0.6%. The resistance is to be determined. The current is like this. What is the uncertainty in the value of R? The resistance is V over I. So the percentage uncertainty in the resistance will be percentage uncertainty of the voltage plus the percentage uncertainty in the current, which means that the uncertainty in the value of R will be the resistance multiplied by the percentage uncertainty of the voltage plus percentage uncertainty of the current. So quickly, doing this, we'll fill in the values, and the answer will be plus minus 1 ohm. Measurements are subject to systematic error and random error. Which measurements have high accuracy? High accuracy meaning low systematic error, and low precision meaning high random error. So the answer will be high random error and low systematic error. Okay, let's move on to question 5. Experiment to determine atmospheric pressure uses the equation P equals to rho GH. What's the value of P when stated to an appropriate number of significant figures? Now that you're an expert already, alright, so we can find delta P will be as follows. So we multiply by 13600 times 9.81 times 0.762. Now we can, once you're used to the uncertainty equation, we can immediately write down that the uncertainty of the pressure will be the pressure multiplied by the uncertainty of the density, the uncertainty of the gravity, and the uncertainty of the height. So we don't have to use too many decimal places to do this, okay? So we can straight away write down the values. Plus 0.02 over 9.81 plus 0.005 over 0.762. Putting this into a calculator, we get a value of 2000. So that means that it's 101,662 plus minus 2000, which really you need to round off to 102 plus minus 2 times 10 to the power of 3 Pascal. So I suppose the closest value would be D. Now let's take a look at question 6. A quantity is determined from the equation shown. Percentage uncertainty P, X, and Q are shown. Without even thinking about it, the percentage uncertainty in Y will be the percentage uncertainty in P plus percentage uncertainty in X plus 2 times the percentage uncertainty in Q. So that will be 6 plus 2 plus 8%, and that will be 16%. Next, a student measures the time T for the complete oscillation of a pendulum. The results are shown in the table. What is the best estimate on percentage uncertainty in the value of G? So first of all, we need to rewrite the equation as G is equals to 4 pi squared L over T squared. So the percentage uncertainty in the value of G will be the percentage uncertainty in the value of L plus 2 times the percentage uncertainty in the value of T. I'm writing it this way because it's an MCQ where working is not required. So that will be 0.001 over 0.420 plus 2 times of 0.1 over 1.3 multiplied by 100%. And that gives us 16%. So the answer is D. A value for the acceleration of free fall is given as 10 plus minus 2. Which statement is correct? Alright, so we know that the actual value lies in 9.81 over here, but the value that's given to us is 10 plus minus 2. So it ranges from 10 to 12. Now therefore, the value over here is inside the range, is accurate. But let's look at the percentage uncertainty. The percentage uncertainty will be 2 over 10, which is 20%. So this is quite lousy. So we can say that the value is accurate, but not precise. Next, 4 sources of error in a series of measurements are listed. Which errors are random and which is systematic? A meter whose scale is read from different angles is called the parallax error. And in this case, it's likely to be, because it's different angles, this parallax error is random, but it might not always be random. Always measures 5 meters too high is systematic. Sometimes sticks slightly, so the needle will be always reading less than the actual. So this is systematic. And this is zero error. I'm sorry, the word sometimes means that it's an unpredictable error. So it would be a random error. Alright, and a meter with a zero error is a systematic error because it's not calibrated. Okay, so the random error will be 1 and 3. The systematic error will be 2 and 4. Of course, you can argue that 3 is also systematic, but let's choose the best answer. Okay, now let's take a look. A screw as a piece of aluminium uses radioactivity. The thickness is marked as 3.2. There's vernier calipers which gives measurements to 0.1 and a micrometer which gives measurements to 0.01. So this talks about the instrument precision. However, the instrument calibration is not stated. So using a micrometer will give a more precise measurement, but not necessarily gives you a more accurate measurement. Okay, let's take a look at this one. 4 identical rods have a square cross section. Rods are placed side by side. Now the measurement over here is 8.4 plus minus 0.1. Okay, and the zero reading over here is 0.0 plus minus 0.1. So for this question only, please don't do this in the practical. The actual length of 4 rods will be equals to 8.4 plus minus 0.2. The reason is because it's the right hand side reading minus the zero error. So when right hand side reading minus zero error, you get 8.4 minus 0.0 plus minus 0.1 plus 0.1. So that is how you get the length reading as 8.4 plus minus 0.2. So the length of 4 rods is 8.4 plus minus 0.2. So the length of 1 rod will be equals to 8.4 over 4 plus minus 0.2 over 4. So this will give us 2.1 plus minus 0.05. So we increase the number of decimal places and you will get a B. Two quantities are measured as A and B. Which of the following has the highest percentage uncertainty? So let's take a look. A plus B will be equals to 195 plus minus 2. So the percentage uncertainty of A and B will be 2 divided by 195. So this is approximately 1%. Now the other one, A minus B, will be equals to 5 plus minus 2. So the percentage error of A minus B will be equals to 2 over 5, which is 40%. Now A times B, okay, will be, once again, the percentage uncertainty of this is 1%, the percentage uncertainty is 1%. So the percentage uncertainty of A times B would be approximately 2%. And this goes to the same for the percentage uncertainty of A divided by B would be also approximately 2%. So you can see that A minus B gives the most percentage uncertainty. And that's the end of this MCQ.